Hello scholars. Today we're going to look at solving quadratics by factoring, and the reason that we do this is a lot of times we can actually find the roots or the zeros or the x-intercepts of a quadratic equation without even graphing it. And we can use some simple steps to do that, and so we're going to look at that today. Again, if you want to write down these examples in your notebook or copy them down as we go, I'll give you a chance to try a few on your own a little bit later on. So to solve quadratics by factoring, the first thing we want to do is take any equation, and if it's not set equal to 0, go ahead and set it equal to 0. And so for the first example, we're just going to say that we're going to set this quadratic equation equal to 0, and then we're going to go ahead and factor the quadratic part in standard form. And so we're going to look for the factors. In this case, the factors are going to be x plus 5 and x minus 2. And then we're going to set each factor equal to 0 to find out when that factor can equal 0. So on the left-hand side, when is x plus 5 equal to 0? When x is negative 5. And when is x minus 2 equal to 0? That's when x is equal to 2. And then we're going to state the two solutions, again using that idea of the curly braces to indicate that those are two separate answers there. So let's do a couple of the examples here in the you try part, and then I'll let you do a few of those on your own, and then you can check your work. So the first one is already set equal to 0, so we can really skip that first step. And so the next step is to get them and factors. And so again, these are going to be able to factor to x plus 1 and x plus 3. So then we can separate them, and we can solve each of these equal to 0. So x plus 1 equals 0 is when x is negative 1, and when we look at x plus 3 is equal to 0, that's going to be negative 3. And so then we can just state the two answers, and notice that I tend to put these answers in order. So the smallest number goes first. You don't have to do that, but that's just the pattern that I'm in. So let's look at the second one. Again, we're looking at factors of 24, and so that equal 11. So you can see that it's going to be the factors 3 and 8. And so then we're going to solve each factor for 3 and 8. And so you can see that x is equal to negative 3. That would make that 0. And x is going to equal negative 8. And that would make that 0. So the important part is that we want to know what are the values of x that will make the entire quadratic equal to 0. Because if they're equal to 0, then we know that they're going to be on the x-axis, or they're going to be what we would call a root or a solution to the quadratic. Okay, so now press pause and go ahead and try some of the other examples that are in the notes, and just see if you can come up with the solutions for each of these examples. So here are the examples that I want you to try on your own. Again, just try them in your notebook, and as soon as you are finished, just again press pause, and in a few seconds we'll look at the solutions. So take a close look, and you could either press pause now, or you just take a look at each of the solutions to check to make sure that you have the correct answer. Notice in 7 and 8, those values, even though the factors are the same, we don't report them as two different solutions. Remember, this is the situation where there is one solution where the vertex is on the x-axis. So that gives us a couple of examples of those as well. So I hope you were very successful in your practice. The second half of today, we're going to be looking at quadratics where the leading coefficient is not 1. So either these are stretched, they're steeper than the normal just y equals x squared, and when we solve these we have to take a little bit of an extra step to look for any common factors that might be there. So in the first example, notice that there is a 3 that is a common factor in each one of those. So the very first step we're going to do is we're going to factor out a 3 out of the entire trinomial here and just set that equal to 0. And then what we'll be able to do is we'll actually be able to factor the second half of this that is the trinomial. So we can break that second half apart into its two factors. And so in this case we're going to have x plus 4 and x minus 1. Then we'll follow the exact same sequence we did before, and we will set each of these factors equal to 0. Now when you look at the first statement, is 3 ever equal to 0? That is clearly not true. So we're going to just say that that's not equal. So there's no solution really to that first factor. Now the second factor, you can see x plus 4 equals 0. That's clearly going to be negative 4 when it would make it 0. And x minus 1, x has to equal 1. So really there's still only two solutions, and we would consider that the two solutions are negative 4 and positive 1. So the only real difference is that we really have to do sort of an extra step in front of that. So if we look at the next example, notice that again all of these coefficients can be factored by 5. So we're going to factor out the 5 first, and then that second part of the trinomial we can certainly factor into the two factors. And then again, when we look at each factor, the first one, clearly 5 is not equal to 0 ever, and we would have x is equal to positive 6, and x plus 2 equals 0 would give us negative 2. So our two solutions for example 2 are going to be negative 2 and positive 6. And again, you can see that when we have a common factor, that's probably the good first thing to look for, is that you can factor out each of those. Now in example 3, there is not a common factor. 2, 3, and 5 do not have any common factors, and so one way that we can find the factors of this is to just take the first coefficient and multiply it by the last coefficient. And if you do that, go ahead and multiply it out, and notice that we're just going to make the last term the product of the first term. So we sort of move that 2 to the end and set it equal to 0. Now here is what we're going to do to factor. So you can see that we can factor this as x plus 5 and x minus 2. Now at this point we have to consider that we did actually multiply that 10 by a 2. So what we're going to do is we're going to divide those two last terms by 2. And in order to make those a factor, if the fraction simplifies, then go ahead and simplify it. If it doesn't simplify, then we're really just going to multiply the entire factor by the denominator. So if we multiply the 2 multiplied by x plus 5 over 2, that's what we'll end up with, is 2x plus 5. And if we simplify the 2 over 2, that's just equal to 1. So this actually can give us our factors. Now, there's lots of different ways that you might have learned to factor with a leading coefficient that's bigger than 1, but this is definitely an easy way to do that. And so then we're just going to again set the factors equal to 0, and notice that this one, when you subtract 5 from both sides, you get negative 5, and then you have to divide by 2. And the other term is equal to 1. So notice that here we have actually a fraction for part of the solution, which is x equals negative 5 halves, and also x is equal to positive 1 for that solution. Okay. All right, and then if you look at the last example, example number 4, you can see again that there are no common factors here. So if there are no common factors, again, we're just going to take that 8 and multiply it by the last term. to get rid of the 8 out in front. And if we do that, notice that again we'll end up with x squared minus 22x plus 40, and we'll set that equal to 0 and then go ahead and factor that. And so x minus 20 and x minus 2 is equal to 0. So again, because remember that we multiplied by 8 originally, so now we're going to divide both of these two terms by a factor of 8 because that's what it was multiplied by. And then we'll go ahead, if it simplifies, go ahead and do that. Otherwise, just multiply the entire factor by 8. And in this case, we're going to do that. So we get 8x minus 20, and we get 8x plus 2. And when we go ahead and solve, this will simplify out. You could simplify before as well, but you can simplify it at the end because it's really just, if you look at 2 over 8, that's really 1/4, and 20 over 8 is really 5 halves. So again, you probably want to keep them as fractions with that. Now, there are some more practice at the on the next at the bottom of the page. And so what I'd like you to do is to again press pause for a little bit and work them out and see if you can come up with the solutions to them, and then go ahead and press play. So again, pay special attention to the answers for each of these. Each of these have two solutions. Notice in numbers 3 and 4, you had to multiply the leading coefficient by the constant in order to get it to factor, and then you end up with a fraction as one of the solutions. So again, these solutions will also be posted within the folder for today as you begin to work on your assignment online.